What we got going today is a little update on the one pager. So the one pager, when we're doing that, we are supposed to do one of each collision, and it says right here, do each of the three collision types. Go to tab 2 to complete the lab. That's for this one, but for many of you, it wasn't working today in class. So let's talk about that. Sketch the graph close to scale. I'll show you the graphs in a moment. Add the conservation momentum equation and the math that shows to be true in your example, which is the equations below it. Add the correct equation with the correct graph. Make sure you identify which cart is more massive, and then explain what you did what you did to make each graph. For example, in graph 3 above, two carts were initially at rest and connected together. Then a spring pushed the two carts apart, causing the lighter cart to move away away more with a higher velocity. The heavier cart is shown in red and had a lesser change of velocity. And then also how the law of conservation of momentum is proven by this lab activity. So if we go back to the actual lab, um, this one basically takes the example and kind of shows you how to do it mathematically. Now you can't use this math because the two carts are actually zero point 0.5 and zero point 0.5. When I did this one, I did two carts that were the equal mass, and you're not allowed to use that. So these examples actually are carts of different masses, and you can tell. I'm not going to tell you which one is which. These are just three examples. What you're going to do is you're going to freeze frame on each thing, and there should be plenty of time. If you look at this one, we've got we've got this one here in red, and we've got this one here in green, and then we've got the numbers that you have here, 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 and here. Hopefully you can see these on your video. This one, we have this one in dark green and this one in kind of a lime green. And hopefully, like I said, you can see these numbers here, here, and here, pointing to just this section of the graph. Once again, this one in the blue, we're just looking at this area here, none of this over here, just the area here highlighted. And so both of them are overlaid right on top of each other right there. And then they are apart here with the light blue here and the, what is that, a purple on this side. Anyways, our numbers here, here, and here. And so follow the instructions in order to do the one pager right here, and explain how the law of conservation of momentum is proven by the lab activity. Now, last thing, in the example here, these two numbers are very close to each other. I'd like them to be a little bit closer, but they're close enough. And the fact that they're close is what we're using to prove the law of conservation of momentum. Remember that there are no unknowns here. We've got a little bit of feedback with the announcements. I'm not sure if you can hear the announcements right now, but um, waiting still. Okay, don't repeat it again. Anyways, there is no unknown here. We're just solving on the left and solving on the right. Anyways, if it didn't work in class, that's understandable. Last thing I almost forgot to tell you is be very careful because the cart masses are really important here. Is that the cart masses, the more massive cart was zero point 0.5 kilograms and the less massive cart was 0.22 kilograms. 0.5 kilograms and 0.22 kilograms. You need to know that. Okay? So hopefully you can do your one pager based upon that. And let me know if you have any questions.